Okay, let's jump right into this explainer because today we are going to radically reframe how we view the chaotic, tumultuous years of growing up. We're diving deep into the fascinating science and psychology of adolescent brain development. And I'll tell you right now, nearly everything you thought you knew about the teenage mind, yeah, it might actually be completely backwards. We're going to pull back the curtain on the underlying biology, look at how totally different cultures across the globe have historically managed this crazy transition, and see how understanding this biological window forever changes how we think about human resilience, risk, and honestly, even time itself. You know, we've all heard it, that massive pop psychology myth that a magical switch somehow flips in our brains at age 25 and boom, we're suddenly fully mature, highly rational adults. Well, digging into the source data reveals something wild. The number 25 isn't a biological finish line at all. It basically traces back to an early 2000s MRI study led by neuroscientist Jay Geet. When the media pressed him to pick an exact age for when the brain stops developing, he threw out 25. Why? Mostly because that just happened to be the age his research team stopped tracking their participants. Maybe the funding ran out, or maybe 25 just sounded like a nice, culturally significant milestone, but the data literally just stopped there. So actually, scratch that whole idea. There is absolutely no concrete scientific evidence of a sharp, magical biological cutoff right at that exact age. So instead of staring at a calendar, waiting for a 25th birthday, think about how vastly different the transition to adulthood can be culturally. Throughout human history, societies haven't relied on a neat little timeline. They've relied on intense, transformative trials. Take the Matisse tribe down in the Amazon jungle. To prepare young men for the hunt, they endure these extreme rituals. I'm talking dripping bitter, burning root juices directly into their eyes and injecting frog poison into their skin just to build immense physical endurance. Or look at the ancient Spartan agoge, right? A completely brutal mandated survival training program that ripped youths from their families to test their absolute limits. Even today, you see this with the Amish Rumspringa, a designated period where adolescents are let go from strict church rules to freely experience the outside world before making a lifelong choice to return. The point here is that cultures universally recognize this specific biological window not as some passive waiting room for adulthood, but as a necessary, intense crucible of trial, independence, and choice. And when we look under the hood at the actual biology, it totally makes sense. Adolescence is a period of massive, almost clumsy brain growth and structural reorganization. It is definitely not a simple, linear march to maturity. The brain is basically overproducing neural connections, creating this vast network of possibilities. And then it goes through a critical, aggressive process called synaptic pruning. It operates entirely on a strict use it or lose it principle. The brain ruthlessly clears out the neural pathways and gray matter that just aren't being used, while heavily reinforcing and insulating the ones that are. It makes the brain incredibly fast and specialized for whatever specific environment the teen is in. As brain researcher Abigail Baird points out, things are literally exploding in terms of brain growth and structural shifting. But here's where things get really tricky. Notice the huge biological mismatch happening during this intense rewiring phase. Right around puberty, the brain naturally prunes dopamine receptors. Counterintuitively, this actually amps up the mesolimbic system. That's the brain's emotion and reward center, which means it suddenly craves larger, more intense thrills just to feel the exact same baseline level of satisfaction. Think of it like a highly sensitive, overpowered gas pedal. Meanwhile, the prefrontal cortex, the logical area that handles cognitive control, inhibition, and long-term planning, the brakes, is still slowly, methodically developing in the background. So fundamentally, teenagers are navigating the world while operating with a massive increase in gas and pretty much a total lack of brakes. This massive neurobiological remodeling perfectly explains why Abigail Bayard compares these chaotic changes to a second toddlerhood. Think about it. How does a toddler learn to walk? They stumble, they fall, they cry, but they possess this relentless internal biological drive to get back up and try again until they finally master their physical environment. Teenagers are going through the exact same highly sensitive, volatile process, but instead of figuring out physical walking, they're trying to master complex social, emotional, and cognitive navigation. It's a period of profound growth, and honestly, it requires a lot of stumbling. Seriously, just think about the behavioral overlap between toddlers and teens for a second. The sudden that's not fair tantrums, the relentless boundary pushing, the extreme emotional hyperbole where everything is the end of the world, and that distinct me mentality. This isn't just teens being difficult or rebellious just for the fun of it. This behavioral overlap serves a massive evolutionary purpose. It's the foundational mechanism for building emotional resilience. Adolescents literally require a huge amount of trial and error to figure out how to function as independent adults. They have to fail, feel the intense sting of those failures, and learn how to self-regulate and bounce back. These intense, chaotic emotions are what provide the necessary friction to build the resilience they'll absolutely need to survive the unforgiving realities of adulthood. And as they're seeking that independence and building that resilience, their social world shifts dramatically. Now, we all kind of assume teens just stop caring entirely about what their parents think, right? Like they just tune them out completely. But looking at fMRI scans of the brain's mentalizing networks, the data actually reveals something really cool. Teens are highly influenced by both their peers and their parents. Whether they're considering a friend's opinion or a parent's opinion, it lights up the exact same region in the brain, the temporal parietal junction, which is responsible for taking in other people's perspectives. So parents, even when it totally feels like they're pulling away from you, your input still profoundly anchors their reality and actively shapes their developing brains. However, peers do have a highly unique, almost supercharged effect on how a teen processes risk. Just think about the feeling of being 16, driving a car with 3 of your best friends laughing in the backseat. The famous stoplight game experiment proves that simply having friends in the room acts as a massive social catalyst. In this driving simulation, adults and college students drove exactly the same way whether they were totally alone or being watched. But adolescents, they made significantly more risky choices, blazing through yellow lights and risking crashes the very moment peers were present. Why? Because the mere presence of friends dramatically amplifies reward sensitivity in the ventral striatum. Socializing literally acts as a dopamine amplifier. It makes the potential reward of a risk feel infinitely bigger and better to a teen than the potential danger. To truly understand how differently adolescents process that risk on a mechanical level, let's try a quick thought experiment. I want you to ask yourself a really simple question right now. Is swimming with sharks a good idea or a bad idea? Just take a second. Okay, if you're an adult, you almost certainly just experienced an instant, visceral, nope, bad idea. Your brain relies on the survival-oriented amygdala and the insula, which give you these immediate, powerful gut feelings based on years of accumulated lived experience. But fMRI scans show that teens respond entirely differently. They just don't have that deep well of life experience yet, so they lack that built-in automatic burglar alarm. Instead, they actually have to pause and consciously compute the risk using their frontal lobes. They literally have to stop and logically calculate if swimming with a shark makes sense. Because of this delayed mechanical calculation, their entire perception of time and consequence is fundamentally altered. They are living in a reality where the intense, immediate present moment feels vastly more real and important than some abstract, long-term future consequence. Now, this realization should completely shift how we view adolescence. Teen risk-taking isn't some glitch in the system. It isn't a developmental error, and it definitely isn't a disease we need to cure. It is a brilliantly designed, awe-inspiring evolutionary adaptation. The teenage brain is quite literally wired this exact way to facilitate the incredibly dangerous, wildly difficult task of transitioning from a state of total safety and dependence on caregivers to a state of total self-sufficient independence. I mean, imagine for a second if humans never developed this biological urge to leave the nest, if this period of hypersensitivity and intense sensation-seeking just didn't exist. Teenagers would never have the courage to walk away from the safety of their parents' fire. They'd never seek out new social or romantic connections. Without this intrinsic dopamine-fueled motivation to explore the unknown and take massive risks, our early ancestors would have never migrated across continents, forged into uncharted territories, or innovated new technologies. This chaotic, messy brain wiring, it's literally the engine of human expansion and survival. And when we follow the actual trajectory of our brains, we can clearly see that dynamic changes don't just magically halt the moment we blow out the candles on our 25th birthday. The latest science shows a much longer, way more nuanced journey. Well into our late 20s and deep into our early 30s, our brains are still actively upgrading. White matter continues to increase through that process called myelination, which basically acts as insulation for our neural pathways. That means our thoughts get faster, more efficient, and better connected. Signal latencies keep decreasing. Brain maturation isn't some destination we arrive at by 25. It is a prolonged, highly dynamic, lifelong process of optimization. So I want to leave you with this final thought. We've seen how the teenage brain is perfectly, intricately wired to learn through resilience, to adapt to entirely new environments, and to aggressively propel young people out into the great unknown. So the next time you witness the so-called immaturity or reckless abandon of youth, what are you going to see? Are you just going to see a frustrating problem that needs to be managed and fixed? Or will you see the incredible, awe-inspiring biological mechanism that keeps our entire species moving forward?
Thanks for exploring this with me today.